Hello, welcome to this session, and thank you for taking the time. My name is Anush Saburi. I'm a program manager with the OS security team, and my team has been working on Windows Hello from the time it started. I'm very excited to come and talk to you about the APIs that you can interact with Windows Hello, and hopefully at the end of this, you'll be convinced that it's actually fairly easy to work with. So just a summary of what you're about to see. We're going to kind of discuss what Windows Hello is, why we build it, how Windows Hello can be used to protect your users from attacks and issues with authentication that normally happens when you use passwords. I'll then try to help you walk through the Windows Hello and how you can implement it in your app and also website. Also, we'll spend some time talking about, okay, so you already have an app that does password authentication. How do I migrate that to Windows Hello? And finally, if time permits, we have a section that talks about the expansion to Windows Hello to companion devices. This is allowing a wearable, like a fitness band or a phone or a headset to act as a factor that is you. So let's just start by some context, why we did Windows Hello. Every day when you open the news, it has become very normal to read yet another news about hackers getting access to data that they're not authorized to, data breaches, Target, Sony, LinkedIn, and the most recent one being the US House of Personnel, where the attackers got access to their personal information, starting from the name all the way to every imagined information that you can do for a user who went through a clearance with this office, and that also includes the president. That, to me, will be the one that we'll be talking for years to come, and arguably one of the kind of the most famous attack that people will be talking about moving forward. But what is the reason that we're seeing so many attacks? And also one thing that we started seeing that is the type of attackers that are behind this have changed. They have moved away from being a rookie attacker to a very sophisticated, sometimes sponsored by governments and very financially sound attackers. And the reason for this is the way we use to authenticate the user is based on an insecure method. As you can imagine, the most common way that people authenticate to websites and apps these days is password. That has been there for years and people have got used to it. But data shows that up to 76% of the network intrusions and data breach can be tied to using a weak password or a stolen password. There are references at the end of the slide which tells you where we got this data. There were some surveys done, and 81% of respondents said that they use the same password across different websites. And the problem with that is once one website gets compromised, the user password for others are at risk. And the most well-known example of this is what happened to Mark Zuckerberg. So his account was part of the LinkedIn data breach, and then the attackers got hold of his password. And then what they did is replay his password against his other social accounts, and they managed to log on to his Twitter and Pinterest account, right? And this is Mark Zuckerberg, right? And everybody does this because passwords, we're human, we can't remember so many things, we start reusing the same passwords, and that's the problem. Outside being insecure, they're also very costly to manage, right? When people forget their password, they have to follow a path, and that normally is associated with some cost. We've seen from some numbers about $70 per each help desk call to reset a password, and up to 50% of help desk calls are due to password resets. So what we have at our hand is something that is insecure and also very hard to manage in a way. But if you want to kind of summarize it, these are the things that we have seen in the past, right? Passwords are easy to clone and steal, right? People give out their passwords on purpose or inadvertently to other people. And also the implementation that stores the password or authenticate with password have proven to be sometimes insecure themselves. And the user themselves, because of the habit of being easier, they start abusing the password and they recycle, share. And even if you start tightening in your policies around password, that normally doesn't quite solve the problem. people will start using and again going through the same password, and maybe you make them remember 4 instead of 1, but they just keep remembering, and no matter how complex you make them, they're just going to come up with 4, and even if you make them rotate it, they just keep using the same 4, right? So it really doesn't solve the problem. The solution to this problem is really well understood across the industry, and the fact that password is a shared secret between you and the server, and it's a single factor. So anybody who has your password can be you anywhere in the network. But with a multi-factor solution, then the attacker has to steal 2 of your credentials or more, which makes it arguably more difficult. So while the solution is well understood, the implementation hasn't get adoption. And the reason for that is the existing implementation of 2-factor authentication, smart cards, one-time password, sending a text message to your phone, they have been proven to be hard to deploy and costly to manage. From a user perspective also, these experiences have proven to be non-consistent. When you go to website A, you have to do one way of 2-factor authentication, and when you go to website B, it's a different one. And this inconsistency have resulted in lower adoption to a point where websites now have to make a choice to piss their users off or make them more secure. And so we did want to solve that problem. We wanted to come up with a solution that is still more secure than password, but also provide convenience for the user in a way that they naturally adopted. And that's where the roots of Windows Hello came from. Windows Hello is a built-in 2-factor authentication into Windows. In Windows Hello, we leverage the device as one of the factors, which takes away the complexity of existing 2-factor authentication. The user always have their device on them. That's how they access the website. So we basically made it intrinsic as part of the user to have that device on them. As the second factor, we leverage biometric, which means that the user doesn't have to remember anything, right? They just show their face or swipe their finger, and they're in, right? And we believe that with this framework, we have a natural way of solving this 2-factor authentication in a way that the user doesn't even have to think about this. And as you will see throughout this presentation, we made it such that the experience of leveraging this 2-factor authentication is consistent across different apps, websites, or other things that would run on the system. And what that means is they don't have to adjust their behavior into different ways of 2-factor authentication. It's always the same thing. Simply show your face. We also have, as part of the anniversary release, expanded that biometric into also companion devices. So let's say your device doesn't have a biometric sensor, but you have a wearable on your hand or a phone in your pocket or a headset in your ear, and these belong to you. We now are capable of leveraging those as a second factor. So if you come in with your band on your hand and you log into the website, even though your device does not have biometric sensor, you can go ahead and do that. We'll talk about how that framework is expandable at the end of this talk. Basically, you can build any companion device that you like to plug into Windows Hello using an app model. Okay, so that's basically the kind of the why we did this work. Now let's look at how we did it. As I mentioned, it's a 2-factor authentication. It basically supports PIN and biometric as a second factor. And the reason why we say it's a 2-factor is that for you to authenticate is something that you know, like your PIN, and something you have, which is your device. Or could be something that you are, biometric, and something you have, which is the device. And that's what makes it a 2-factor authentication framework. And one of the things that we have done, and it's not scope of this talk, but we have had a few others, is we're also aiming to replace existing enterprise 2-factor authentication like smart cards with this. Imagine that being able to secure the user the same way as a smart card does without having them carrying an extra piece in their pocket, right? And the deployment for this is not as ad hoc and separate as smart card is. It's actually built into the system. I'm not going to go through those. We have like 2 other tracks at Ignite that talked about this. Just search for Windows Hello for Business, and you can see how that looked like. Now, why is this important for developers? You'll see at the API definition that they're really simple. You don't have to have cryptographic knowledge for it to work. And we made it as simple as possible. And also we made it consistent across our apps and also our websites, our browser, Microsoft Edge. And also it supports protecting enterprise content as well. Now, I talked about browser, and the first question I normally get is, okay, is this only something that Microsoft Edge will support? And the answer is no. When we started thinking about Windows Hello, we wanted to make it such that it's a standard across the industry, because we wanted to protect our users no matter what platform they use, right? And it was important for us not to build yet another only Microsoft two-factor authentication solution. With that kind of thinking behind that, we joined FIDO. FIDO is an alliance of companies that care deeply about killing passwords. When you look at the board members, you see all the big names and brands, right? And financial sector and also browsers. We're part of FIDO. Google is part of FIDO. Firefox is part of FIDO. And the idea is to come up with standard APIs that provides two-factor or strong authentication to developers, such that developers doesn't have to deal with inconsistency across websites. And one of the outcomes of FIDO Alliance is a specification that does exactly that. That specification was submitted to W3C, and W3C is the standard body who's going through the spec and making it to a point where browsers can pick it up and implement it. What we did in the anniversary release was to take a snapshot of one of the early drafts that W3C had and implement it into Microsoft Edge. So everything that you're about to see is based on that spec. As like any other standard, that spec has been evolved, and we'll continue upgrading our implementation based on that spec. But at least what you could see today is kind of semantically, what are the experiences you could build using Windows Hello in a website? And I should also warn that as the API changes, the signatures might change into a way that the existing one breaks. So we don't recommend building production websites on it, but they make a great entry point to build proof of concept for understanding like the things you need to think about when dealing with this new type of credential. So you'll see some demos about this, and perhaps I can do right now. Let me switch to this PC. And this is, by the way, a website that you can also access. The link is public. And so this is a proof of concept that we have built that shows you how this works. This is Microsoft Edge, and this website supports username password. When I click on sign in, let's see what happens. So I have typed in the username password for this guy. The thing that I see is a page that the website draws and says, hey, we noticed you have Windows Hello on your system. Do you want to start using it next time instead of typing in username password? If I click on start using Windows Hello, or in other words, opt into this, this device in front of me supports face authentication. I've already enrolled my face on this device. And when I say start using Windows Hello authentication, the system sees me and greets me and asks me to click OK to continue to approve this using Windows Hello, and I'm logged in. So when I do log out next time and come back to the same website, go ahead and click on log out, I notice a new button that says start using Windows Hello. And if I click on it, all I have to do is, again, show my face and click OK, and I'm logged in. And the key point here is that I don't have to remember any more password, right? It's so natural. I'm just using my face. But under the cover, what happens, and you'll see later, is this is not using password authentication. This is a two-factor authentication. But there's no more text message to my phone. There's no more, oh, where's my phone? I should find it. It's all based on my face. And the other thing that I started this presentation with is let's make sure that the experience is consistent across websites and applications. So let me switch to an application that supports Windows Hello and show you how that would look like. Dropbox has already implemented Windows Hello in their application. So I've set up a PIN. So every time I open the app, I have to type in the PIN before I get it. Let's do that, and then let me go ahead and enable Windows Hello for this device. Let me go to setting page. There is a security here, and you can see there's a toggle for using Windows Hello. When I enable that, let me now close the app and run it one more time and see what happens. As you can see, the first thing that happens, again, is looking for my face. And if you notice, the gray UX is exactly the same thing that happened when I launched the browser. same experience. And this is the thing you want to get at, right? Like no matter what application the user interacts with, it's always the same gray UI that shows up and scans for my face. So hopefully that kind of gives you what you're about to see today, right? These are the things you can build with your application if you start leveraging these APIs. Let me go back to, I've put some videos on the slides if you wanted to play with them. And also I believe there is a link in the PowerPoint for their website, so you can also go ahead and look at the code yourself. All right, so these are the videos. So, okay, hopefully by now you kind of have a good context of why we did Windows Hello, what kind of experience you can build with Windows Hello. And I now want to do a little bit deep dive on what are the things under the cover for Windows Hello and how that works. So we talked about factors, right? We talked about PIN as one and biometric as another. This is how we know the user is present in addition to device being present. As I mentioned also that we'll support companion device with anniversary, so now you can use a wearable or a phone as a way to prove that it's user. One of the things that we made sure was that the experience of enrolling face is unified across form factors, right? Let me switch back to the device you were seeing and quickly show how I interact with setting up my device. This is the Windows setting page. And when I go under account and sign in option, this is where all the enrollment or management of biometric is, right? So if this device supported fingerprint and face, I would have seen an option here under face recognition that said fingerprint. And the key point is this is done by the system, not the application. From application perspective, you should assume that it's already set when the user gets your application, okay? So that's one thing that is very important is that the enrollment and management of these second factors is taken away from the app. And all the app has to do is to manage the credential. We manage the second factor ourselves. And as also mentioned, we wanted to make sure that we give good visibility to this so the user doesn't have to know that they have to go to setting page. Setting page is just a fallback. The main way that they interact with Windows Hello is when the user sets up their device for the first time, they actually see the biometric enrollment right there. And this is the first thing they do, which we promote them to start enrolling their face. And the enrollment happens, and I can show you it's very fast. It happens under 10 seconds. And then they're instructed to set up a backup PIN in case face authentication wouldn't work, and which they do, and then they're good. And now they're quite ready for your application to start leveraging it. If they want to change or improve the recognition or add a new finger to the set of enroll fingerprint, they can go to the setting page that I showed you. So in terms of the credential, so we talked about the factor. This is how we know it's the user. Now let's move to credential. This is how the actual authentication happened. And this is where we tie the secret, the credential to the system, right? And this is why we count the device as a factor in the two-factor authentication. So in summary, the user provides a PIN or biometric, which is one of the factors that is leveraged by the OS to unlock access to the credential. The credential itself is protected by a module in the system called Trusted Platform Module that doesn't expose that secret to the OS. So operating system can never see the credential. All it can see is a signature from that credential. I mentioned signature because we leverage actually asymmetric cryptography here, very similar to smart cards. So there's no shared secret between the client and the server. The server only gets what is called the public key of that portion, which is public, as the name suggests. So even if one server gets compromised, there's nothing there to replay against other servers. So that's basically what we just discussed. The private key, which is your credential, is protected by TPM that even the OS cannot see. Neither the app, neither the server. It only stays in that module. And then the public key is shared with everybody. And again, it's public. It doesn't matter. And this is kind of showing you how things work, like end-to-end, right? The user either provide a PIN or biometric here, and then that is passed somehow to the TPM to release the access to the credential, but not the actual credential. The app then can work with the server in a protocol that we will talk about more to prove to the server that the credential is on the system without actually presenting the credential. And that results in a successful authentication. And again, given that the TPM and biometric have to be present before authentication happens, that's why we call it two-factor authentication. So hopefully by now you have kind of a context of how Windows Hello enrollment works, how under the cover we protect the credential. I want to walk you through how one should start leveraging this in their framework. And there are different ways that users interact in terms of credential, right? There is a use case where I'm setting up an account for the very first time with your server, which we call enrolling a new user. Today, the user provides their name, their family name, a password, confirm password, and they're in. With this one, we're going to replace that, type in a password and confirm the password with a new thing, right? This is the first topic. And then we'll talk about the actual authentication. And also this new credential is per device. So it's not like password that is one across all of the user devices. So there are some interesting caveats that one has to look into. And we also talk about multiple accounts on the same device. So let's do one at a time. Enrolling a new user. So I'm just visiting your website for the very first time, and I want to sign up. The thing you should do in this flow is first make sure that the device is capable of Windows Hello. And what that actually means is that the user has set up a PIN. That's all it means. Biometric is optional, but as far as the user has a PIN, they can start leveraging these APIs. And once you do that, then there's an API that you call that creates one of those credentials, a keeper on the system. And there's also a protocol that you can leverage to make sure that this credential is protected by TPM. It's called TPM key attestation. I'm not going to go through number 3 in detail, but if you want, I can point you to references that you can read more. The API that you use to create a keeper in the system is very simple. If you're using an app, it uses Key Credential Manager class. Sorry, I think I jumped ahead of myself. The API that you use to check to see if the system has Windows Hello is very simple. On WinRT, there is an API called isSupportedAsync, which returns a true or false. And in web authentication, the JavaScript call is called makeCredential. I'll deep dive into these APIs later. And then that, at the end, results in a credential that is returned to your application or website, which then you have to store on your server. Again, this is a public key, so it's not a secret. You don't have to protect it the same way as password does, which is great. But obviously, you have to expand your scheme on the server to support these new data fields, right? There is the key, the public key. There is the attestation that proves that the user is tied to a system, and also a device ID. Again, the credential is per device, so you may want to track that for things like managing devices that the user have. If I lose a device, you need to revoke that credential. And this is the actual API that you use for creating a key. If you notice, the JavaScript API is the same for both checking the Windows Hello and creating a key. For WinRT, we have a different API called request_create_async from the Key Credential Manager class. And this basically is the one that gives you out the key. We'll go through a code walkthrough later. I'm just trying to give you an overview, and then we'll deep dive to it. Now, in terms of this is the W3C spec that I was mentioning, right? And this is the API that they standardize. Again, with the caveat that this is coming from an earlier spec, so things have moved. But just to give you an idea. So makeCredential API returns a promise called MS assertion, which has 2 attributes. One is the type, which is set to FIDO220. And this is the name of the working group that worked on this spec. And then there is an ID for the actual credential. This is how the system then can access the key in the future, something that, as a developer, you need to persist, either on the client side, like a cookie, or send on the server side. This is basically how we find the key to use. Also, for MS assertion has another interface called MS FIDO credential assertion. And basically what this is in the return value is telling us the algorithm that was used to create that key. In Anniversary release, it only supports RSA keys, padding with PKCS 1.5. It then returns the public key in the JSON web key format. This is the actual thing that you need to store on the server side. And then an attestation statement, which I kind of hand-wave at. For JavaScript, we don't support that yet, but it's something that we plan to support. In WinRT, we do support it. And then And then the transport hint, and this is not something we support, but just to give you an overview what this is, one of the scenarios that we plan to enable in the upcoming release is an ability to use your phone or a USB dongle, security dongle, or a wearable to have your credential. So it would be the scenario where I have my credential on my band, I go to a new website and I log on with it without having to set up a credential on that device. And that thing is going to also be standardized, so then we will support different transports that can talk to that thing. It could be USB, NFC, Bluetooth, and embedded means leveraging Windows Hello on the system, right? So the specs supports that, and we plan to add that support in future. For now, we only support embedded because that's all we do in this release. And when the make credential is called, there are some parameters that are passed. This is basically a way for the OS to show information about an account. The first one is the RP display name. RP is the relying party, is basically the server. So something like a Microsoft account server. Then we have the user display name. This is the friendly name for the user. Anush Saburi is a user display name. And then the account name is my account. anush.saburi@outlook.com is my account name. And then the user ID is a unique number from my account on that website. It's basically GUID. And finally, an account image, which is something that we can use and show to the user when they're picking an account. So it's some kind of a hint to the user. Now, we don't support most of these in Anniversary, but they're there for future use once the spec finalized, and we do plan to support them. And the spec also allows for the server to kind of limit the algorithms that can be used and also the authenticators that can be used. If you remember, I talked about remote authenticators like a band or a phone. The server can dictate policy on what are the acceptable ones that one can use. And this is done through some like a standard GUID for the device. So there is some kind of a database that has a mapping between, here's an iPhone, here's the corresponding A GUID. And finally, there is a challenge that the authenticator have to sign to prove that actually the authenticator was present at the time of creating the key. So that's the kind of creating the credential. Next is actual authentication. So the way that works is, as I mentioned, it's asymmetric cryptography. So the server and the client have to exchange some kind of nonce that the client use and make a signature with. And this is the reason for using nonce is to make sure we protect against replaying the same signature. So it's a kind of a fresh signature. And this is actually what that is, right? So the client application starts talking to the server and asks for a nonce, gets it back, signs it with this, and then TPM actually signs it. So the application doesn't have the key to do it, asks the TPM to do that. And before the TPM signs it, it asks the user to type in their PIN or provide their biometric. And that's basically what number 4 is about. And once that's done, the challenge is signed, it's sent back to the server validates the signature, and if it's authorized, the authentication is successful. And the key point here is that the private key is never sent to the server or application. The biometrics is never sent to the application. These all happen within an operating system. And the only thing that the application gets and the server gets is a proof of that happening, which is a signature. And because this is a challenge response, these signatures change. So if you want to make analogy, it's almost like having one password for each authentication, throw it away. That's kind of how it looks like. And this is the same thing in a kind of a better visual, right? So request a challenge, sign it, send it back, verify the signature, and authentication succeeded. Again, we talked about this, this protocol is not subject to replays or man in the middle, given that there is a challenge response for each authentication. There are 2 API surfaces that you can use. One is for the browser. This is the Get Assertion API. And in WinRT, there is a request sign async that again comes from the key credential class. So the JavaScript one, the Get Assertion, again returns the promise MS assertion. In terms of input parameter, it comes with a filter of the credential types. Basically, if you have multiple key IDs for the user, you can pass it here. And then this credential spec is again set to FIDO 2.0. So that's that. That basically tells the PC which credential to pick and use to sign in. And then this is a string that you can use to the user at the time of authentication. So you can say, hey, you're about to authorize this purchase for this amount. Are you okay with it? And we'll show this UI or this string in the UI that you saw in that gray box, if you remember. We're going to show the string and sign it with the credential that proves to the server that the user actually saw the string. And the result is the MS assertion as a promise. It basically contains a signature that is formatted in a very specific way. And the final result is a UTF-8 encoding of the signature. And it contains two different parts. This is a hard string that is set for anniversary release, and this will change in the upcoming one. But basically, it has the challenge here and the string that was shown to the user. So these are both part of the signature. OK, let's do a quick walkthrough of project we have for this. It's on GitHub, and that's where the link to it is. Let me do this. This project contains both the client code and the server code that you can leverage. Let me go ahead and do this. Maybe it's the best if I can show you from the GitHub directly how this looks like. OK, so one thing that you will notice is that the name for this is said Microsoft Passport. This was the marketing that we used in the previous release, but now we changed it to Windows Hello. So keep that in mind. You see the reference to Microsoft Passport throughout the sample. All right, so the two pieces, there is a server code and there's a client code, and which in these two folders. Let's start with the client code. All right. There you go. OK. So the first thing I want to show you real quick is promoting the, sorry about that, promoting the user to start using Windows Hello. Let's look at the code and just look at the API call here. So if you notice here, this is where that flow starts, signing with Windows Hello. And if you look at here, this is the kind of API call that creates the actual credential for the user. And let me see, what do I go for? There you go. So this is the API call. The first thing it does is checking to make sure. Oh, actually, it's not quite easy to read. Let me see. Can you guys see well? Yeah? Better? OK. So I'll just point at it. This is the API call that allows you to check. This is actually the one that creates the credential for the user. This is the request create async. And it has two parameters. One is the user ID. This is the unique way that you use to track the user and will be used as a key ID in future. And then this is a flag that you set that says for this user ID, if you already have a key, overwrite on it. Don't create two keys for the same user. And the return, let me actually switch back here. The return then can be used, as you can see, it's an object from a class key credential retrieval result. And one of the members is a credential, which has a method called retrieve public key. And this is the method that you can use to extract the public key and then send it to the server. And by the way, when this API is called, the request create async, this is when the user sees a pin prompt or the biometric prompt. If you remember on the web page when I said start using Windows Hello, something showed up and scanned from my face. That is basically due to the API call. And what else is important here? Okay, so I think that at this point we have the key set up. Now, let's look at the registration code. There you go. So this is the code that actually registers that key with the server. Now, this is just an example of how to do it. This is left for your implementation. You have your own transport. You have your own protocol of talking to your server. This is using JSON and HTTP post, but you can pick whatever makes sense. The key point here is you need to make sure that this public key is somehow sent to your server. In this code, we're using this. So we create a JSON request, and we post it to the server here. And we also pass the user ID and the computer name so the server can track the credential on which device it is. Okay? So at this point, the credential is created for the user. One thing I want to call out, let me see if I can find that API call. So if the, let me see. One of the things that you need to check for is that if the user has set up PIN on the system. And if not, you need to tell the user to go to setting page and set up one. Let me see. Let me see where, if I can show you that real quick. Is supported in sync. If you remember, that was the API call from is supported async. Perhaps this one. Okay. It might be a different page that has that API. But there is the API that you can call before promoting the user that allows you to verify to make sure the PIN is set up. And if not, you need to now tell the user, go to setting page and set up the PIN. Okay, let's move on. So now let's look at the actual authentication code. So that would be here. Okay. So if you remember, there was a challenge response involved, and then the application is supposed to actually perform a signature with that challenge response. Let's look at how that works. So this is the API that is used actually to sign the request here. And what that is basically, it first opens the key using the user ID that was used when creating the key. And then that is used to make a signature with the, hold on a minute. Yes. So then the code actually reaches out to the server and requests a challenge. And this is when the server creates a random number and gives it back to client. Let me quickly show you how this is done on the server code, which I have opened. Oh, maybe I should open a new one here. Let's look at the server code real quick and see how that looks like. Server code. If you go to data, oh, actually, no, it's on the authenticator, the controllers. If you go to controllers, the authenticate controllers, there you have the API that generates this nonce. And again, you can use request challenge here. You can use any way that you want, but here we're using the CNG APIs to create a random number, and then we send it back to the client, right? And this code kind of shows you how that's done, okay? So now let's go back to client side and see what happens to the nonce that was just received. Okay, I'm gonna go back to here, to the CS, and to the first one. So now that I got the challenge back, I need to sign it, and the signature is done in here, right here. So this is the code is converting the challenge that was returned into a string, and then sending it to the request sign async. This is when the user sees yet another pin prompt or a biometric prompt. And what happens after that is that the application in this case have to submit this response to the server. And what it does is actually sends back the user ID, the key hint. This is a way for the server to look up the key and verify which key to use. It's optional. And then the actual signature back to the server. And then the server has to verify that signature. There are many standard libraries that you could use for performing the RSA signature validation. And this is basically the way authentication would work. And let me see if there's anything else that we need to, yeah. So that, as you can see, there are only 2 API calls on the client side and 2 API that you need to build on the server side. And then obviously we're going to talk about the management part on how you manage this credential, but hopefully you're convinced it's really not that complicated. So that's that. Let me switch back to my PowerPoint. Okay. So where were we? Okay. So now let's talk about existing applications or websites, right? So you already have some authentication using most probably password. And you need to start thinking about, okay, how do I start telling my users to start using this, right? In the demo that I showed you, it was one example where there was a promotion page that says, hey, you want to stop using password and be more secure. And that's something that you need to think about, and it's something you would like to build depending on the design language you would like. And once you do that, then after that is when you create a keeper like what you just saw in the sample code I showed you. You register it like the sample code I showed you. And you also maybe take note of the device that the user came from. The reason why that's important is because it allows you to then go back and expose all the devices user have. In case they lost one, you can revoke it, right? And again, this is because credentials are per device. And then, and that's it. You need to also expand your database on the server to store this. But one thing that I want to emphasize again is, given that these are not private data, you don't have to have HSM anymore. You don't have to secure this anymore. These are public data. You can even list them on the internet if you want. So that's the beauty of this. We talked about multiple devices many times. One thing I want to call out is, in a world with no password, right? How do you authenticate a user on a new device, right? In everything I showed you, it was type in username, password, let me promote you to Windows Hello, and then stop using password. But what if in a new device that I just picked up, I don't have any password? How do I start the authentication? And the way to solve that problem is using one of the other existing devices that the user has. So for example, you could say, well, type in your username, and then based on the username, you figure out the devices user have and said, okay, go ahead from one of these devices and approve that you want to add this device to your set of devices. Perhaps that would be a notification that comes on their phone or a notification that comes to one of their PCs. And then once they approve it, then this device becomes capable of doing Windows Hello, and then you don't need to do this anymore. So there's a one-time setup that you need to go through. The other thing is, given that this is a strong authentication, it is a good practice to use a strong proof of before the first enrollment. In other words, before the user actually starts using Windows Hello, it's a good idea to maybe challenge them with a second factor for the last time, because you're kind of transitioning from a one-factor to two-factor, and if the whole security of the system is based on the one-factor to bootstrap a two-factor, you kind of have that problem, right? So it's a good idea to have a kind of a two-factor authentication before you set up a new two-factor. So perhaps it could be something like type in username, password, send a message to your phone for the very last time, and then that's it. You will never do this again. You now have moved to this new two-factor authentication that is much more secure. And the two ways you could do this, with Microsoft Account, we had to solve a similar problem, right? Microsoft Account in Windows 10 supports Windows Hello out of the box. And we had to solve this problem because we had Windows 7 users, we have non-Windows users that only have password. And so the path we took was what is called delayed migration, which means that we promote as many as users we want to Windows Hello on Windows 10 platform and make them secure on those platforms. And then obviously that will move the attack surface to older platforms or non-capable platforms. But the thing is, once you start kind of scoping down the attack surface, then you can also come up with other mitigation. For example, perhaps if you're coming from a down-level platform, you can do limited stuff. Or maybe you will see a challenge response to your phone every time. But if you're coming from a modern platform, all you have to do is to show your face, right? Or maybe if you're coming from a lower platform, the contents that you can access are limited. Maybe you cannot change your billing address. But if you're coming from a modern platform, you have more flexibility. The key point here is we can't make a claim that we're going to kill the passwords tomorrow. There will be a migration, right? And the point I'm trying to make is the migration can be done in parallel. You can still benefit from Windows Hello on modern platform and make it as a stick for people to leverage this moving forward. And at some point, when you have good indication that most of your users have migrated, this is a time to actually turn off passwords from your server, which is what immediate migration is about. This is a goal we have for Microsoft Account on Azure AD and on-prem AD, and we're really hoping that you can join us in that journey. There are other ways that you could leverage Windows Hello in your platform. One is what is called the user consent verifier, which is simply verifying user is present without changing your authentication flow. This doesn't solve the password problems or the security problems. It's just a faster way to know that the user is in front of their device. So those are the two API calls that you can leverage. And you can also, if you don't want to manage your own identity, you can federate to other identities in the system using Web Account Manager, which I will not get into. But for example, Angry Bird can leverage Facebook credential through this. Now, if Facebook implements Windows Hello, in a way, Angry Birds also gets it. There is an application on Windows iHeartRadio that have federated to Microsoft Account. And as a result, because Microsoft Account supports Windows Hello, they get it for free. So those are kind of the three ways you can leverage Windows Hello. And what I'm hoping that you've taken out of this session before I move on to the companion device framework is we did this work to solve an authentication problem. And it's not just a hypothetical problem. It's based on the facts and number of attacks. It's a real problem. It's just a matter of time that the name of the company shows up in one of these lists. And so it's something that across the industry, everybody agrees we have to solve. We believe that we have a standard way to do this, and we really hope that we can do this together. And we made the API really simple to make the entry bar really low for people to get it. And we have dedicated team within Microsoft to help developers build their application. So if you're interested, please let us know, and we can definitely help you. So that's the first part of the talk, how you can leverage Windows Hello in your application or browser. The second part is about Windows Hello companion device. So basically the thing we were trying to solve was many devices today do not have biometric sensors on them. They can still play in the Windows Hello land because the user can just set up a pane, but we wanted to kind of come up with a way to also enlighten them to leverage Windows Hello. We've done this in many different ways. We have worked with partners like BioKey to enable external fingerprint readers, but we also build a framework in the system that allows developers to plug into it and build interesting applications. Let me show you one of these so you can see how that looks. Oh. You know what? I think I thought I don't have audio, but actually I do. Is there a way we can fix the audio in the presentation? Let me see. Yes. How can I do it?
The screen unlocks automatically when the user. with Microsoft, and leveraging the Companion Device Framework for Windows 10, RSA enables seamless and secure unlock of Windows 10 machines, depending on the required identity assurance level and contextual data, driven by administrator policies. In this example, a user on a public network with their smartphone nearby will be required to provide a gesture on their smartphone to verify their presence or identity. On a trusted or corporate network, the screen unlocks automatically when the user's smartphone is near their laptop and the user intends to unlock it.
So as you can see, this is an app-driven model, right? And the idea is that anybody can build an app that plugs into this. And we have a large set of partners that are building apps for this framework, all the big names that you would imagine, OEMs, device manufacturers, and so on. And the idea is, you carry devices with you. You have a phone in your pocket. You have a wearable on your wrist. You have some companies give out these security fobs to their employees, or within Microsoft, we have badges to go through doors. Why can't these be used as a second factor? Why can't this be the fact that it's you, right? You have a badge that gets you through doors. Why can't the same badge get you to Windows? And that's basically what we did, right? We wanted to enable these scenarios in a way that it scales up. Now, and kind of visually, the way to look at it is the credential still is tied to the device, but it's expanded to a companion device, right? And the way that works is simply through an app that gets installed in the system. And this app talks to a new service that unlocks Windows. The app itself is then responsible to talking to a companion device. Now, these green boxes all belong to a developer. And the key point is because they belong to the same developer, the developer can pick whatever transport they want in here and whatever logic they want to implement here. So in the case of RSA, you notice that if you're within CorpNet, the phone can simply unlock your PC if it's in your pocket and you're nearby. And so the logic is enforced here. But if you go outside the CorpNet, then you need to swipe your finger on your phone or unlock it before it works, right? And this logic is something that you can leverage to build different types of experiences. And again, given that you have choice here, we have solutions that work over NFC, Bluetooth, USB, Wi-Fi, and so all of them are coming, but it's an open platform, so this is something that you can leverage to build other creative solutions that maybe we haven't thought about. In terms of how this is supposed to work, and we have, again, another program that we have built to help developers build solutions for this, we kind of recommend that this is a way for two devices to talk to each other, right? And like any other conversation, there must be some kind of handshake that happens between the two devices that tells and proves that they want to talk to each other and that they're authorized to talk to each other. You don't want a random nearby phone unlock your PC, for example. So we recommend that, as a developer, you build certain signals around your solution, right? One is, as a user, I have an intent to unlock my device. This could be hitting the spacebar on the PC, or it could be a movement I do on my band, but it's something that shows the user I want to do this, show the system I want to do this. The second is a disambiguation. So if you have a phone that is paired with multiple PC, we need to find a way to tell the system which PC the user wants to unlock. And finally, it's a way to know it's user present, right? It would be something like swipe your finger on the phone or something similar like that. The user flow for this is actually fairly easy. The user sets up a pin, like I showed you for the app, and then they download the app for that device. These devices, like wearables, they already have apps for other reasons, like set up the band, or pick a name for it and all that. So the same app can be leveraged for this framework. You don't need to build a separate app. And then the app registers the device with the PC, and the unlock can start happening, right? And that's basically the flow that all of these scenarios will follow. In terms of the protocol overview, we wanted to make sure that this unlock only happens when these two devices are available. And the way we did it was we come up with a secret that is split between the two, And the user can only unlock the PC if two are somehow present, right? And that's basically the way this works. And so every companion device that plugs into our solution has to support storing this secret, which we call HMAC keys. And there are two of them. One is used to authenticate the PC to the companion device, and the second is used to authenticate the companion device to the PC. The application that sits in between is not capable of unlocking the PC without the device being nearby, because the keys are not given to the app. It's some kind of HMAC result of the key is given, which is useless if the device is not present. In terms of registration, there are two simple APIs that you can use to perform this. First is, actually before I go there, I have to mention, the way this works is that the application registers the background task on PC, right? So when I come nearby the PC, the background task is the entity in the logon UI that talks to the device and actually performs the unlock. So the first thing the app has to do is to register that background task. And then it then has to talk to the device to establish the two secrets that needed for unlocking. Then the application called this API request start registering device async, which is set up the relationship with this companion device. And then it calls finish registering device async to finalize the kind of registration. And then at the end, the companion device gets two copies of the two keys, and then the PC has one key, and then they can use that for future unlock. And that's basically the API call. The device ID is something that the OS tracks to know which device to talk to. The capabilities are basically telling the system what kind of device this is. Does it support secure protection of the keys? Does it support secure verification of user presence and stuff like that? The friendly name is one that the PC picks and the app picks for management in the future. The model number is again for management, we don't care. And these two keys are the ones that I mentioned that are actually behind the protocol and provide security. And finishing it, you can also store some configuration data that you can use to actually talk to your device. For example, a Bluetooth MAC address. This is just kind of a general storage for your application, and this is available to you across users, right? So you can support like switching user with this solution. The unlock is very simple. The way this works is the PC keeps giving information and state to the application or the background task on where the user is. I've swiped up or hit the space bar or just locked my PC. So the application keeps getting this state machine from the Windows, and then based on the state machine, it can actually decide when to unlock, right? And so this is done through here when it goes from a wait state, I just lock my PC, to I just swipe up or collecting credential. And then the application calls this API, start authenticate async, and this is when the application said to our system that I'm ready to unlock. And then this is when the application gets back a challenge and sends it to the companion device to compute, and then return it and call finish authentication async. And if everything goes on, the unlock happens. So basically, there are two API calls to call for register and two API calls to unlock. I'm kind of going through this quick because it was not quite part of the kind of context you want to present, but I also just wanted to kind of raise awareness for it. There are some links that you can go and look. We have a dedicated video and walkthrough. And also we have a program which we help you build these applications. So all the partner lists that you saw, they had one-to-one kind of relationship with us, and we brought them on campus and helped them build that. So if you're interested, let us know. And we could definitely make it work. And again, these are the two APIs that one has to use to unlock the PC. All it does is passes a device ID, the device that is trying to unlock the PC. And as a result, it gets back a nonce. And then that nonce is sent to the companion device for HMAC operation, and is sent back to our service via this API. There's a timing between the two API calls, so you need to make sure it happens within 20 seconds. I'm going to skip this code walkthrough because we are kind of short on time, but I'm going to leave 15 minutes for any questions that you may have. please use the microphone.
Hello? Is there a way to integrate this with IDFS 2016? So I see Azure ID, MFA, but with IDFS?
So the question is there a way to integrate this with ADFS 2016? Which part, the companion devices or the first part, the websites? Yep. Right, so if the application can federate to ADFS, and if the enterprise have enabled this, then yes, but it's not it's a deployment that the enterprise have to do for this to work, right? So there is actually a session on Windows Hello for Business that talks about what are the deployment requirements to do that, but it's not an application choice, it's more about setting up the right servers. If you couldn't find the session, let me know, I can help you get it. Yes, go ahead.
Yeah, I'm wondering how to make use of this in a shared computer, more of a how to handle the biometrics, let's say a shared computer with 200 employees that want to easily log into the system or get authenticated.
I see. So the Windows Hello, as you can imagine, is more about the one-to-one relationship with the PC. And so it doesn't quite work well when you have more than 5 or 10 users logging into the same one. The companion device, and the reason for that is the kind of the matching algorithm slows down when you have a large database to compare against, and we didn't want to go there. Theoretically, it's possible that all those 200 users enroll their face, except that when you have 200 profiles running on the system, it just becomes super slow. But let's say you have a family of 5, the Windows Hello will provide a fantastic experience of, if each member of the family shows up in front of the PC, they would just log on to their account that belongs to them. So it works perfectly for that, but if you have like a manufacturing line or some retail floor that there are users that come in and go, it has a one-time setup experience that doesn't quite work well if you have like the same employee going across different PCs. So it doesn't quite work well for that scenario. This other companion device is a more promising one if you have your credential in your pocket, because then you can take that and go log on to any device without having to type in username and password. That's the kind of direction we feel like we should take instead of using biometric because of that initial enrollment headache. And especially if you have to do it more than once throughout the day, it just doesn't scale and just kills the magic. Does that answer your question? Yeah.
Talk about the companion app on the PC.
Yeah.
So it sounds like right now it's like a third-party agent or an application.
Yeah.
Are there plans for you guys to have some sort of generic Windows service that accepts any third party?
So the current implementation does have a Windows service that talks to the third-party code. The thing we couldn't do and we didn't want to do was to come up with ways that we talk to device directly, because we weren't sure whether all devices follow the same way, right? For example, we had partners that have a custom NFC protocol that they use to talk to their devices. And even if we try to do that, we wouldn't be able to talk to those devices. But when that partner builds an app, it allows them to scale up better. That's where we are with the solution. And if we find ways to standardize the way 2 devices can talk, and this is something that FIDO is looking at, we'll potentially look at doing the same thing here, where we leverage standard API for transport, and then any companion device that builds those API can talk to us natively without having to download an app. But currently, we don't have that standard out there, and that's why we ended up doing this app-based model. Sure. Any other questions? Yeah.
Are there possibilities to backup and restore the credentials, so the key pair of the user? So in fact, when I try to roll out new devices, hundreds, thousands of new devices, so that our users don't have to go through every app and reapply and do this bootstrapping again.
Yeah, you brought a very good point and interesting point. I think this is the one that we always get. the nice thing about password is you set it up once and it works everywhere, right? With this one is, as you mentioned, is a per device credential, which means that you have to set it up. So currently the solution actually relies on, as you said, every new application the user has to go through the setup experience once. Very similar to how, like, if you install a bank app on your new iPhone, you have to do a one-time step up, right? It's very similar to that. But can we do better? Can we get to a point where my account is set up on all of my devices? Well, that's where the idea of a portable credential come into place. If you remember when I was talking about the FIDO API, there was a section about the transport type. Remember, it was a USB, NFC, and all that. The idea behind there is that you have something in your pocket, like your phone or a wearable, that has your credential. So when you go to a new PC or a new device, you launch the browser, it just detects it, you swipe your finger, you're logged in, right? And then that already bootstraps something locally, and then you're good to go. So in a way, the user experience is always I either touch here or touch something in there, and I'm logged in. Now, under the cover, we're kind of bootstrapping one with the other, but that's the kind of thinking or solving the issue you brought up. Like the first, we actually call it death by provisioning within Microsoft, but basically, how do I minimize the number of times I have to provision credential number of devices? Well, one of the things we wanted to do is to make sure the credential is tied to your device. So it goes against that promise to not to do that. So we want to have provisioning per each device. But can we do a better job in terms of the first-time provisioning? And I think this remote credential devices is a way to get there without having a lot of user friction. Does that answer your question? Or?
Yeah, but there's no possibility to back up and restore my key pair from one device to another device.
That's right. And the reason why we don't want to do that is if you have a mechanism to back up a key, that mechanism can be leveraged to actually steal the credential, right? Remember when I was talking about the credential, I said it goes on the TPM and it can never leave it, right? And this is because a malware can pretend to be that agent that does recovery and then gets the credential and then replay it somewhere else, right?
Yeah,
so
but technically, the key is not in the TPM. The TPM is only used to decrypt the key and
That's
do
right.
the signing operation.
That's right.
So if you provide a kind of API to decrypt the key and put it maybe into a PKCS15 container protected by certificates, so maybe a certificate from the smart card of the user, we could make a secure transfer mechanism to transfer the key pair from one device to another device, or to back up and restore it. So that when we change the devices, or if one user has several devices, we can have one key pair for the user.
Right. So you're absolutely right. Like there are ways you could leverage one of your devices as a backup. But the thing I was trying to say is, in the FIDO model, when you leverage a remote device to bootstrap a local device, it's technically that, except that if you have two PCs, A and B, instead of grabbing the key from A, using this portable device and putting it B, the portable device has one unique credential that is like can vouch for others' keys, right? So instead of having all of your keys on this device, just have one key and then that bootstraps other ones. But you're right that if you do like one key for the user across all of their devices, it helps with the scheme on the server side, the number of keys you have to store. But it also has a problem because if one of the devices is lost, you need to go and rekey everything, right? And so it's a balance one has to strike in terms of like, do I want to go with the security and on my management side, like one key for the user across all devices, or do I want to have separation of credential? But you're right, it's theoretically possible to go that route. One thing I want to call out, again, the same API that you call to do this export and send it to the remote device, the question is what stops the malware to call the same thing and pretend it's one of those remote devices, right? So, there are certain things we need to think through, but you're right, that's one option to solve the provisioning problem.
Yeah. Another question, is there a possibility to create, so the key pair is always created by Windows Hello.
That's right.
There is no possibility to use enterprise PKI, so existing PKI user certificates, user key pairs we already have. To say, okay, use this key pair when registering this user, because these public keys we could, in our backend systems, distribute, and that would solve this bootstrapping first logon process.
Yeah. Absolutely. This is where the Windows Hello for Business part of this come into place. So this is not a kind of an application model anymore, but yes, we do have support to kind of concise or collide your PKI certificates with Windows Hello for Business. It does need some server-side changes, but the idea would be, remember when I was showing you this first setup experience? In that experience, when the user is setting up a PIN or biometric under the cover, we're reaching out to your PKI, grabbing certificate, putting it and protecting it with the Windows Hello. And then when the application calls for a certificate, the Windows Hello is the one that actually releases access to the certificate. So we obviously have that already supported for the hybrid environments where you have Azure AD subscription. We don't yet support it for on-premise scenarios, but it's something part of the roadmap of supporting. But exactly what you said, and the beauty of that is the user, when they enroll their face, everything under the cover is happening. They don't have to think about do two different things. Yeah.
Thanks.
Yeah, sure. Any more questions? I want to thank you all for attending and appreciate your questions and feedback. These are some additional resources if you wanted to get in touch with us. And we also have a session at the Microsoft Showcase and the Expo Hall. So feel free to stop by, ask us questions, and thank you.